We are going to definitely go back. Right, okay, let's go. So, the law of the conservation of mass states that no matter is lost or gained. Do we need to write this? No, don't write this just yet. So the law of the conservation of mass states that no matter is lost or gained. Okay, so there's stuff is not going to arise out of nowhere. Okay, things don't just appear out of nowhere. So if 5 grams of a reactant goes into the reaction, then you will expect 5 grams to come out of the reaction. Okay, that's what we mean by nothing is lost or gained. Mass is always conserved. Conserved means, if I say conserve your energy, people, what does that mean? If I say conserve your energy, what does that mean? Guys, I just want you to understand this concept, yeah? So don't worry too much about writing it. Good, to retain, to keep, yeah? Save your energy, right? So that's what it means. Mass is always the same. Mass is always the same. Right, guys, if you ran a shop, okay? If you ran a shop and you were selling items, okay? And in the beginning of the day you had 100 items and you sold 10, what are you expecting to find on your on your shelf? So you have 100 items, you sold 10, you're expecting to find, as a business owner, the 90. If you don't find 90, you find 82. What are you gonna suggest? What are you gonna infer from that? Exactly, as the young people say. Sorry guys if you're gonna get cringed, but it is your fault. You're listening to me. You just got finessed. No, I'm kidding. Right, okay, so mass is always the same, right? Okay, and if something's missing, something has been stolen, right? And that doesn't make any sense. Therefore, the total mass of reactants is equal to the total mass of products. Always, okay? So the mass, I'm sorry, I do apologize for the second-hand cringe burn. So the reactants is always equal to the products in terms of mass, right? The sum of relative atomic molecular masses of the reactants will always be the same as well, okay? As the sum of the relative atomic or molecular mass of the products. A precipitation reaction in one in which two solutions react to form an insoluble solid. Now this is weird. Has anyone done a precipitation reaction in class? You probably did one and thought, whoa, what is happening? What is this sorcery? So here is test tube number 1, and we mix it with test tube number 2, and what do you get? Hold on, I'm gonna go back. Aluminum. Hold on. Wait, so we got two solutions, and what do they make? So what did it say? So precipitation reaction is when you have 2 solutions that make an insoluble solid. So 2 liquids, and when they react, what do they form? Has anyone done this in class? A solid. This is called precipitation. Oh yes, that's right, man. Yes, that's correct. Could there not be gases? What do you mean? Specifically, precipitation refers to liquids. So the solid they form is insoluble. Not like ice, because ice is all about temperature. Here, the temperature is constant. Guys, let me know in the chat if that's making sense, yeah? So a lot of people think, oh, you know, what's going on here? How have we got a solid from 2 liquids? Regardless of what is happening, regardless of whatever is happening, right? Mass is conserved. Okay? So whatever happens, mass is conserved. If I had a 500 milliliter bottle, and by the way, this is where the water example is quite good. If I had a 500 milliliter bottle of water, and then we froze it, it's still going to be 500 milliliters, but of H2O ice. Is that making sense? So the state can change, but it's exactly the same thing, right? But it's solid, correct. So let's continue moving, people. Let's continue moving. Where are we? Okay, so if the reaction flask is closed and no other substance can enter or leave, right, then the total mass is constant. So do we all understand the concept of a closed system? Do we all understand the concept of a closed system? Good. A closed system is where nothing can enter or exit. Right? A closed system is where nothing can enter or exit in terms of mass. Right? Can energy enter? Can energy enter? I'm talking about in chemistry, not in physics, yeah? I'm talking about a closed system in chemistry. Can energy enter? The answer is yes, through heat. How does heat travel? How does heat travel? I'll give you a clue. It's a letter beginning with R. I mean, there's two other ways, but I'm not talking about them. I'm talking about the one that begins with R. How does heat travel into a system? I like the guesses. I do. I appreciate the guesses. It is radiation, right? Well done for those. For the few that said, actually for the one person who said it. So well done. Right? It travels through radiation. Does that make sense? Okay. So let's say, for example, I had a hot cup of coffee. Now, if you bought a hot cup of coffee, after about 3 minutes, let's say you didn't open it for 3 minutes, what do you expect to happen when you lift that lid? What do you expect to happen when you lift that lid? What drips onto your sleeve or your arm? Right? So you see a bunch of steam. Have you noticed the lid is always like covered in some condensation? So the lid, you'll see a whole bunch of water droplets on there. Right? You'll see a whole bunch of water droplets on there. Okay? Why is that? Because it's a closed system. So even though it vaporized, it condensed back into a liquid, but it's all within the same system. Okay? So this is what a closed system is. And in a closed system, I always expect the mass to stay the same. Okay? What if it's not a closed system? What if it's not a closed system? What would happen to what could happen to the mass? So let's say it's an open system. So here's a beaker. I've put something in. Here's a liquid and acid. I've thrown in some solid, and it starts to fizz. You know, fizz. What happens to the mass? Correct. Thank you, Nathan. Thank you, Yasmod. Thank you, Adam. Exactly. What happens? Thank you, Tariq. Exactly. The mass goes down. Okay. The mass decreases. Okay, because some of the reactants have left. Some of the reactants have left. So, for example, if we had CH4 plus oxygen, which gives us CO2 plus H2O, could I expect for this in a closed system for the mass to go down? Could I expect for the mass in a closed system for them? By the way, this is not balanced, yeah. In an open system. That's what I meant to say. In an open system, can I expect this to go down? Adam, you know what? I'm gonna entertain that actually. 2 and awesome. Thank you for that. Right. Can I expect the mass to go down in an open system? Why? What's the culprit here? What's the culprit here? If it has an open lid, what's causing the mass to go down? I need everyone to lock in, please. Have a look. We've got methane plus oxygen gives us carbon dioxide and water. So come on, guys. What do we think? But which one though? What's the culprit, Josh? That's the one. Guys, don't make me put state symbols on this. Please. Don't make me do it. The question I asked was, if this was a reaction in an open system, do I expect the mass to have decreased? That's my question. The answer is yes. In an open system, it will go down. And the reason it will go down, what's the culprit? CO2, carbon dioxide. Okay, carbon dioxide will rise and leave. Why would carbon dioxide rise and leave? What quality does it have that allows it to rise and leave? Why doesn't it just stay? That's the one. That's the one, Hassan. That's the one, Adam, yeah. So guys, remember, carbon dioxide, this is an exothermic reaction, which means this is really hot. So anything warm, any warm gas is going to be less dense than air, and it will rise away, okay? But we'll talk about that later when we get to physics. How are we feeling at the moment, people? So we're understanding this. We know what a precipitate is. We know what a closed system is. We know what an open system is. We know what the conservation of mass is. Where else are we? What else did we do? I feel like I missed one thing. Oh, the last one, yeah. For example, the reaction between calcium chloride and sodium sulfate produces the precipitate of calcium sulfate. If carried out in a closed system, then the mass before and the reaction will be the same. And then they gave us the chemical equation. Right, here we go. So let's have a look at this. What would this look like in a lab? Pretty straightforward. Guys, when you are in a lab and you are measuring the mass of your reactants, how do you do it? Let's assume you're using an electronic scale. How would you do it? So you are in the lab, you're about to measure the mass of a substance. You know it's extremely important to measure the mass. How are you going to do it? How are you going to do it that's in a correct way? If the equation is not balanced, will it be an open system? No, you just got to balance it. You just got to balance it. Correct. You know what that's called? Begins with a C. Harris, let me know if you can hear me. You know it's an open system after you've weighed everything. Thank you, Harris. So once you've weighed it, then you know. Who's a bit unsure about what I mean about how you measure the mass? So you take your electronic scale, you place your conical flask or whatever it is on your scale. Then you calibrate it. You set it back to 0. Then you put the substance in, and then you take the reading. Do you guys remember doing that? You might have heard your teacher say, 0 your scale, 0 your scale. Calibrate. Calibrate means you take it back to 0, because you don't want the reading of the conical flask. Oh, by the way, let's say you didn't calibrate your scale. Let's say you didn't do that. What can you do later? What can you do later? You can just deduct it, right? You can just take it away. Correct. Right, okay, so here you have it. Calcium chloride plus sodium sulfate gives us calcium sulfate and sodium chloride. So here you have it. Okay, here's the reaction. Here it's taking place. There you go. So why did they do it like this? This is a really bizarre way of doing it. Well, what did they want to ensure? What did they want to ensure? Calibrate means when you take a conical flask, put it on the scale, you 0 it, then you put the substance in. Very good. 1 on George, 1 on Adam, 1 on Josh. Very good. 1 on Nathan. So what happens is these two things will mix. You started inverting it. Start inverting it. Okay. And then what happens? These two things will mix. And regardless of what happens in the reaction, even though it's a precipitate that's formed, this will have the same reading. So really what you have here is a closed system, right? A precipitate in an NaCl solution. Right, okay. Moving on. Don't need to do that. Don't need to do that. Sorry guys, there seems some stuff that I can skip over. Alright guys, I'm going to quickly test you on something, yeah? Don't worry if you don't know how to do this. We're going to start easy. Everyone ready? You don't need to note take for this. I just need to make sure you know it so I don't have to spend time going through the topic. Two people responded. Okay. This is carbon dioxide. Can you tell me how many carbons present in this molecule? This is a molecule, by the way. Call it a compound if you like. How many carbons in this CO2? If you don't know, feel free to say no. I have no idea. Okay, so the carbons are one. One carbon. How many oxygens are there? That's okay, no worries. No worries. How many oxygens are there? Come on, Harris, you got this. Come on, Zia, drop an answer in. Very good, 2 oxygens. So if I was to draw this molecule, should just be a bit smart how we do this. So guys, this which color is the carbon? Which color is the carbon? I've just drawn the molecule. Yes, well done. So I've just drawn this molecule here. Which one is the carbon? The carbon is the one in the middle, right? This clear one, this white one. Right? Does that make sense? Okay, we're gonna run this back. I need you guys to respond faster because I don't want to spend too long on this. Why is it a double bond? We'll get there later. That's a very good question. Okay, H2SO4. How many hydrogens do I have? Spam the chat, people. I need to move up fast from this. You saw how much biology was left over. Horrendous. Right, good, thank you. So 2 hydrogens. How many sulfurs present? So the sulfurs are one sulfur. Don't worry if you're unsure. Okay, so that little 2 belongs to the hydrogen, and in algebra you don't write 1x, right? In algebra you don't write 1x, so the same thing here, we're not going to write S1. How many oxygens, guys? Thank you, Nathan. How many oxygens? Well done, I think we're getting the hang of it now. Okay. Okay, a few more examples. Anyone know what this is? Sorry, I got the numbers wrong. Anyone know what this is called? Ooh. Okay, so no, it was supposed to be, but I got mixed up. Go ahead, Harris, give it a go, man. Throw it all together. Thank you, Zeus. Thank you, Manuel. Right, I'll give you a clue, yeah? So the metal always, well, the metal you see listed comes first. That's chromium. And that's oxygen. Now, whenever you see an oxygen, more than 3 or more. Whenever you see, well done, Adam. Whenever you see oxygen 3 or more, it gets the name 8. Okay? So this is potassium. Well done, Nathan. Go on. You're almost there, Harris. Go on, Tarek. Throw it all together. Well done, Hassan. Yes. Right, potassium. Crow. And then, remember, 3 or more is 8. Right, okay, that was just a bit of a side quest. Potassium chromate. Guys, how many potassiums are there? How many potassiums are there? In the chat, flood it. Whoa, hold on. I saw your question there, Zia, but unfortunately, some people are saying the same number 200 times in the chat. I don't know what... Oh, wait, no, hold on. What was even Zia? What else? Yes, that's right, Nathan. That's absolutely spot on. Yeah, I did say spam. Yeah, I did. But I didn't mean it like that, though. Right, okay. Potassium is 2. How many chromiums? How many chromiums? Use the other ones, by the way, to help you, yeah? If you don't know, use the other ones. This is a really good example. Very good. The chromiums are 1. And lastly, how many oxygens? Thank you, Annie. Thank you, Zia. Thank you, Mania. Thank you, Harris. Right, there are 4. Okay? Right, you'd think we're done, wouldn't you? We are clearly not. If anyone could tell me the name of this, you're a legend. Well, apparently we have some legends in the chat. Apparently we do. It's not methane, but it's close. We have a couple of legends. Well done for all the legends. It is propane. This is propane. Right, okay. That is a big 3, okay? Now, little numbers. Don't worry, we got it. Monkeys eat peanut butter. Yes, that's a good way. I just remember it as MEPB. Or the sad Arabic song. Have you guys heard the sad Arabic song? I'll find it somewhere and send it to you guys. Oh, some people have heard it. So the little number is only the atom before it. So affects only the atom before it. Nathan is not messing around. Is only the atom before it. Hold on. And the big number is everything. Did you guys hear that? The big number is everything. Okay, so for example, if I asked you how many carbons do I have, you would typically say 3. But it's 3 times 3. So how many carbons do I have? Yo. So I guess high key, this is going to be helping you, right? Okay, so 9. Okay. That's the one, Harris. Yes, that's the one. I think you guys are all learning paper 2 at the moment, or starting to learn paper 2 at the moment. Okay, guys, I need everyone to help me out. What's the hydrogen? What's the number of hydrogens? Yeah, that's right. We're not talking about that right now, though, yeah? Just hold that back. Now, remember, I've got a big 3, guys. I've got a big 3. So it's 3 times 8. It's 3 times 8. Thank you, Tarek. Yeah. Thank you, Sia. Thank you, George. Everyone's alert. Good. Well done, Rahel. Okay, so we've got 24. Okay, so what if I had 2 CO2? Can everyone tell me the number of carbons? The number of carbons. Quickly, guys. The keyboard must be getting jammed right now. Very good. And the number of oxygens? Thank you, Zeus. Very eloquently put there. Fantastic. 4. Okay. Have we come to an end? Do you think we have finished? No, we haven't. Right, okay. There's one more culprit on the table. Our good friend, brackets. Okay. Thank you, Annie. I've got the recording. So, who's seen the brackets and decided to panic? Hopefully no one. Right. Okay, so the brackets is everything in the brackets, okay? So, for example, how many carbons do I have here? Sorry, carbons, calciums. How many calciums do I have here? A little bit, Ali, a little bit. Yo, a lot of people answer with 0. That was quite funny. How many calciums, guys? 1 calcium. How many oxygens do I have? Very good. Well done. 1 oxygen. And how many hydrogens? Very good. Okay. 2. Sorry, did I say 2? 2 hydrogens. What is the number outside the bracket though? Wait, where? Are you asking me about an example, or are you asking me about this example? How is it 10? No, it's not. It's 1 oxygen, 1 calcium, 2 hydrogens. Sorry, hold on, guys. Oh, right. Yes, of course. There's supposed to be a 2. I didn't write it down. My bad, guys. My bad. I'm gonna do another one. Wrote that whole example and didn't even get to benefit from it. Guys, can everyone give me a group 2 element? I need a group 2 element. Quickly. It is an emergency. I need a group 2 element. Bro said sodium. It's unforgivable. Right, magnesium. We're going to go with magnesium. Okay, here we go. Right. How many magnesiums do I have? 1. Very good. How many oxygens do I have? Thank you, Nathan. Harris, what's going on, man? What's going on with the keyboard? Right, well done. 2. By the way, is everyone happy why there's 2? Because there's 1 in the bracket, but there's 2 sets of brackets. So there's 1 in the bracket, and there's a little 2 outside. So everything in the bracket is doubled. So 2 oxygens. Too many oxygens. I like that. And how many hydrogens, guys? Hydrogens. So there's 2 in the bracket, and there's 2 lots of them. There's 2 in the bracket, and there's 2 lots of them. So all together, can everyone understand why there's 4? I really want to make this the last one. Very good, 4. Okay, just a question, person. If you write H2O or as OH2, like that, is it still the same compound? It is exactly the same compound, and you're really only going to do stuff like this in A level. But even then, I don't think I've ever seen it look like this, because I'll tell you why. When it's written like this, all the bonds are occupied, and if all the bonds are occupied, I agree, Harris, yeah. If all the bonds are occupied, that means there's never a reason for it to look like this. So for example, you may see it written like that, with only 1 hydrogen. Yeah. Oh, okay, I see. I see what you mean. Guys, you can't just reverse things, yeah? You can't just reverse things. Definitely, man. Yeah, I need to find a way to put it in. It's gonna happen. I'm gonna go back to the drawing board and figure it out. Is everyone okay with how this looks now? Yeah. Everyone okay with it? I'll let it pop back up in terms of questions later. So I need to know how this looks, because I need to balance the equation, right? I need to balance the equation. So let's go ahead and do this one. So we're going to do a reaction when, let's say for example, let's say this is the equation. So the question says, when magnesium oxide reacts with nitric acid, HNO3, it forms magnesium nitrate, MgNO3, 2 outside, and water. Write a symbol equation for this reaction. Okay, let's go ahead and do this. So MgO, by the way, if you want to go ahead and do it yourself, please do. I'm just going through it on the board. So HNO3, it forms magnesium nitrate. Have they given us the thing for magnesium nitrate? Yes, they have. And water. Have I finished the equation? Nice, thank you, Nathan. Have I finished the equation? Have I written that correctly? Thank you, Manuel. Guys, have I used all the information here and written that correctly? Thank you, Adam. Yep, good. don't you need to expand? But there's something I need to do before that. Go on, Harris. What's the error? I need to add. It does say and water. Okay. Okay, right. Does that answer your question? Okay, so let's go ahead and balance this. That's right. So I'm going to list out all of my atoms. Is that all of my atoms? Are those all my atoms? Are there any more? Are those all my elements? Okay. So, not yet, Tarek, not yet. So how many magnesiums? I've got 1. How many oxygens? I've got 1 here, and I've got 3 here, so I've got 4. How many hydrogens have I got? I've got 1 here. And how many nitrogens have I got? I've got 1 here. Let me know in the chat if you're happy with my numbers. Or if you want me to just double, go through another number one more time. Let me know in the chat if you're happy with my numbers. Ooh, we're getting there, Zeus. But I can't go there without everyone knowing this, because those calculations are going to get messy. Okay, awesome. Right, how many magnesiums here, people? 1. How many nitrogens, though? How many nitrogens? It is 2. How many oxygens? How many oxygens? Can everyone write this one down? I want to just see if we're awake. Now remember, guys, there is 1 chilling over here. I see the correction. I see it. There is 1 chilling right here, people. That's the one. Thank you, George. Thank you, Yasma. Thank you, Adam. So let's go, people. Go, 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 go. So are we happy with 7? Okay. And nitrogens. How many nitrogens? Oh, did I just mess up the letters? What am I doing? Oxygen 2. Did I put 2 for... What is this? I was looking at the wrong one. Sorry, my bad, guys. Hold on. That's 6. That's 7. I'm messing up all the letters here. Hydrogens is 2. And what's last? Nitrogens. Nitrogens are also 2. Everyone happy with the numbers? Thank you, Nathan. Everyone happy with the numbers? Awesome. Okay, so we've got to balance some stuff first. We've got to do some balancing. So let's go ahead. Don't really want to disturb the magnesiums. So let's go ahead and disturb the... Who thinks I should put a big 2 here? Who thinks I should put a big 2 here? See, if I put a big 2 here, I'll have how many hydrogens? 2. And how many nitrogens? Guys, I'm really sorry. I'm just getting my letters mixed up today. 2 hydrogens. How many nitrogens? 2. How many oxygens? So 6 and 7. I know how that sounds. Guys, is that making sense? Yes, we have a very clued on chat today. Is everyone happy with that? Yeah. Could I put a number and it not work? Does that mean it's all going wrong? Or can I just take that number off and retry it elsewhere? I'm going to give you a tip here. If metal, and by metal I mean the first thing in the compound, is unbalanced, start with the metal. Okay. How are we feeling so far? It's a lot of positivity in the arena this evening. What's the point of that tip? It just gives you a starting point. Just in case you don't have a starting point. Like you just don't know where to start from. So if you see that the metals are unbalanced and it's the first thing, then start with that. Has everyone got a periodic table with them? And by that I mean the one from AQA, the one that you get in an exam. You just go through some simple calculations. Yes, please, guys. Can everyone go ahead and find a copy on Google? You know what? I'm gonna just plug one right here. Hold on. So if you go into Google and type in AQA periodic table PDF, it's like the first one that comes up. Actually, no, it's the second one. So it's good to get used to this one because this is the one that's going to be in your exam. There you go. Too right, Hassan, too right. Right, everyone okay with that? You have that in your book. Okay, awesome. Yeah, this is the one. You want to get used to seeing this one. Right, can you guys see this monstrosity here? Ammonium sulfate. It is, I agree. I agree, Adam. Can everyone see this? Ammonium sulfate. Okay, so I want us to work out, and if you know how to do this, go ahead and work it out. I want us to work out the relative formula mass. The relative formula mass. So that's what we're calculating. It's okay, you don't need a calculator for this one. Oh, but you lost it though. That's still a nuisance. Actually, you might need a calculator for this one. Use the Google calculator. Right, relative formula mass. Right, so for relative formula mass, the thing that we need to do first is list out our atoms. Are these all of our atoms present in that compound? Let me know in the chat. Are those all the atoms present in the compound? Nitrogen, hydrogen, sodium, that's right. Oh, sorry, sulfur and oxygen. Thank you, Nathan. Thank you, Adam. Thank you, Hassan. Right, people didn't waste any time. Good. How many nitrogens have I got? I've got 2. How many hydrogens have I got? I've got 4 times 2. How many sulfurs have I got? I've got 1, because there's no numbers there. And how many oxygens have I got? I've got 4. Everyone happy with the numbers? To work out the relative atomic or relative formula mass, a relative atomic mass is when you is singular. All you do is you find the atom. So sodium is there, and no, not sodium. Nitrogen is there. I'm going to look for nitrogen. Can everyone tell me what group nitrogen is in? Can everyone tell me what group nitrogen is in? Just checking, people. Just checking. Fantastic. Okay, nitrogen is here. So in group 5. When we're looking for relative formula mass, we're looking at the mass number, which is the bigger number, the top number. So I'm doing 2 times 14. Then for hydrogen, I'm doing 8 times 1. For sulfur, what number do I want? Here's sulfur, by the way, somewhere. Where is sulfur? Thank you, Nathan. Very eloquently typed out there. Right, what number do I want from sulfur? I need to know we're locking in. I can't let you lose easy marks to stuff like this. Thank you, Tarek. Yeah, thank you, George. Thank you. Very good. So the number is the top number. Harris, where you at? Well, it's by providing a lot of detail. So it's the top number, guys. We want the top number, which is 32. And lastly, what's the number that we want from oxygen? What's the number that we want from oxygen? Okay, 16. Right, let's go. So that's 28. That's 8. That's 32. That's 64. Then you just add it up. So 28 plus 8 is some number. 32 plus 64 is also some number. And then you just turn it into another number. Who got 132? I think most of you did. Okay. So we're going to look at another question. Would it be... For this, there's no unit for now. It's relative as well, so there's no unit for now. What is all mass is relative to? Interesting question, right? Right, okay. The chemical formula of the fertilizer ammonium nitrate is NH4NO3. Calculate the percentage by mass of nitrogen in ammonium nitrate. So what is the atom, what is the element that we are focusing on? Zia, what are you thinking? What is the element that they are wanting us to focus on? Why did I not write N2? Why did you write N2? Why did I not just write N2? I don't know. So they want us to focus on, so the chemical formula for fertilizer is this. This is the chemical formula. Calculate percentage by percentage mass of nitrogen. They want us to focus on nitrogen. Oh, I see. Okay. That's because the hydrogens are bonded to the nitrogen. So in this displayed formula here, they want us to understand that the hydrogens are bonded to the nitrogens, and one of those. I will do, George. Thank you very much. Okay. So let's go to this next calculation. No worries at all. Okay, are we ready? Yeah. So how many nitrogens do we have? So we have one nitrogen. No, we have two. Hydrogens, we have 4. Oxygens, we have 3. So 2 times 14. Guys, where did I get the 14 from? Thank you, Nathan. Thank you, Adam. Where did I get the 14 from? If I was looking at a periodic table, where did I get that number from? Is it the bigger number at the top, or is it the smaller number at the bottom? Very good. It's the bigger number at the top, and that number is called the mass number. This is the smaller number, and it's called the atomic number. So that's where I got the 14. So that's times by 1, and that's times by 16. So that's 48. That is 4. That is 28. Guys, can someone do the honors and add those up? So 48 plus 28 is going to be 30 plus 50, which is 80. So the RAM is 80. Okay, or relative formula mass, RFM is 80. Where did you get the 2? No, hold on. Where did you get the 2 in the nitrogen from? 1 from here and 1 from here. No worries. Okay, so and which one do they want us to focus on? Nitrogen. So we take, what's the mass of nitrogen? 28. Right, that's the amount of nitrogens, 28. One of them is 14, but I've got 2, so it's 28. So we turn it into a fraction. 28 divided by 80. Guys, what is this, please, as a percentage? Thank you, Nathan. What is this as a percentage? Do we times it by 100? Yep. Yeah, you do. You times it by 100. Who got 35%? Yes, it is 35%. Well done. Okay, so let's say for example I am asking you to, so I'm gonna make a question up, okay? That's a 9, by the way. Yeah, that's a 9. And this is a snapshot of a periodic table. There you go. Go on, Harris. You got this. Go on, Zia. You got this. Rahel as well. Let's go. That's right, Isma. Zeus, the question's in the purple box. That's okay. Just give me like a minute. I'll show you how to do it. Anyone else confused? I'm seeing a bunch of answers coming through though. Come on, guys, as you know. What's an alcohol group? I wrote it here. I gave you a hint. Okay, so first things first, what's my... is everyone watching, by the way? Is everyone watching? So if you were stuck with this, just let me know if you're watching. Okay, so this the what do you call it? The compound was C4H9OH. So how many carbons did I have? 4, right? And hydrogens. How many hydrogens did I have? So I've got 9 here and 1 here. 9 here and 1 here. Thank you, Tarek. Thank you, Nathan. Thank you, Manuel. And how many oxygens do I have? Very good. I have only 1 oxygen. Now remember, when I'm timesing it, I'm interested in the mass number, which is the top number. So what am I timesing this by? 12, 1, and 16. So that's going to be 48. That's going to be 10. That's going to be 16. Guys, can you add those 3 numbers up, please? The alkaline group is what makes something alkaline, right? So does that mean alcohol is alkaline? Basically, the alkali group is a group is group 1, And the reason it's called the alkali group is because when you react it with water, the substance that comes out the other end is actually alkali. So that's why it's called that. The alcohol group, we'll talk about it when we get there. So 48 plus 10 is 58. 58 plus 10 is 68. 68 plus 6 is 74. Who got 74? Who's on board still? Who's okay with this calculation so far? For those who struggled, let me know. Okay, so we've got a total of 74. Now, what was the interest? What was the thing that we were interested in? Find the percentage mass of the alcohol group. What is the alcohol group? Remember, I didn't leave you guys without a hint. The alcohol group is OH. So what is the mass of OH? Can everyone tell me in the chat, what is the mass of OH? O is 16. H is 1. So to me, that is 17. Right? Because here, there's only one alcohol group. Why do I add them? Because it's O and H. I want both of them. So 16 plus 1. So I put 17 divided by 74 and I times it by 100. Which bit do you want me to explain? Yes, you do multiply. Oh, no. You don't multiply them here. You're just adding them because you want the alcohol group. You want just the alcohol group. How I got 17? Okay. What's oxygen? I go to my periodic table. It's 16. What's hydrogen? I go to my periodic table. It's 1. So I do 16 plus 1 and I get 17. Is that okay? Right, guys, I'm going to move on from that calculation. Let me know how are you feeling so far, guys? Okay, that's what we want to hear. And I'll just say, how are we feeling at the moment? Are we okay? Okay, I don't need to go through that. That's already been covered. Okay, there's another thing I want to go through. Why won't we use 48 for the last one? We used N's. Oh, we used N's mass last time because they asked us about it. They asked us about nitrogen. But this time, they didn't ask us about nitrogen. They asked us about the alcohol group. Okay, so very quickly in the chat, guys, can everyone tell me what is an isotope? So we're kind of going on a bit of a tangent. What is an isotope? The reason I'm going through this on a bit of a tangent is only because I've looked at the time and I want to squeeze in a couple of more calculations. Very good, yeah. So an isotope is essentially a different form, a form of a chemical element, okay, that has the same protons, right? The same protons, but a different number of neutrons. So well done for those who put that in the chat. So you better lock in. You better lock in, Rahel. Right, a version. Well, I'm going to say a variance. Does everyone understand what I mean by the word variance? An alternate version. Another version. Okay, with the same number of protons and electrons. And a different number So my question to you guys is the following. So I'm looking at samples of carbon, okay? Carbon is the most famous isotope. Anyone know which one I'm referring to? Rahel, man, you got this. You got this. Hang in there. Hang in there. Very good. The one that we that is widely known as carbon 14. Guys, what do we do with carbon 14? What's its uses? What can be done with it? It's not to do with crude oil. Digging up bones. It has something to do with digging up bones. Yeah, well done, Adam. It's to do with carbon dating, right? Carbon dating. So we use it. Yes, we use it to determine the age of organic matter. Very good. So carbon dating. So a version of an element with the same